Hi, I've got a story to tell you, and that story is about insects, and in this case the insect is a dung beetle, and about a gas, and the gas in this case is carbon dioxide. And the story goes like this. The insects are in trouble. They are in decline across the whole of our planet. Their numbers are going down, and the numbers of species are going down. So that snowstorm of moths that used to greet the headlamps of your car at night has gone. And that has disappeared across the planet in places as far apart as national parks in Costa Rica and in Germany. Insect numbers are in decline. And should we worry about this? Well, we should, because insects offer us what are called ecosystem services. They do little jobs in the background that are massively important for us and the rest of the planet. And one of them is pollinating our crops, for instance. The other is recycling waste. Flies and their maggots recycle nutrients back into the soil, and plants can use those nutrients. And then also insects like beetles turn over that soil, and they allow air into it, and they allow water into the soil. And there are other jobs like pest control that insects do while we're not even watching. So they're a very important group of animals to the whole planet. What is the cause of this loss of insects? Well, the short answer is we don't know. It could be pesticide use, because we use lots of pesticides to protect our crops. It could be habitat loss, because as we clear land to plant those crops, we also build buildings and we also put lights on those buildings. So in fact, it could be light pollution is affecting the insects. But again, we don't know. And also these effects are patchy. They don't occur evenly across the globe. They tend to occur where people are concentrated. Even global warming is not even across the planet. It is patchy, occurring in different levels at different parts of the Earth's surface. So none of these are ubiquitous effects across the planet. However, there is one effect that we think we've had on the planet, which is literally global, and that is the increase of CO2 in our atmosphere. So we have to think of the atmosphere as this thin skin of breathable air clinging to the surface of the planet that allows life to continue as we know it. Unfortunately, we've changed that atmosphere. By burning fossil fuels for our industry, we've increased the level of CO2 from about 230 parts per million pre-industrial levels to now 400 parts per million. We've pretty much doubled the concentration of carbon dioxide in our atmosphere. And we know what the climate change consequences of that are, that the CO2 acts as a blanket, trapping heat against the Earth and causing this uneven rise in temperature across the globe. But all of these effects that I've described so far are patchy. They tend to be concentrated around where people are on the globe. What about direct effects on insects themselves from CO2? Well, we do know that plants grow better in elevated CO2, but it makes their tissue harder because they store more carbon in that tissue, and it makes them harder to eat. So therefore, other insects that aren't herbivores, such as dung beetles, shouldn't be affected by this and shouldn't show a decline. It could be the way that we breathe, or it could be the way that the insects breathe, that the elevated CO2 is affecting them and the way they breathe. But that seems very unlikely, because we know as air-breathing animals that we can increase the level of CO2 in our lungs by 100-fold, and then simply by breathing out, bring that level back down to zero without any effects whatsoever. So we have no expectation whatsoever that small insects living in the soil should be in any way affected by elevated CO2. However, that is precisely what we did find. If we reared dung beetles in elevated CO2, as the CO2 increased, the mortality of the beetles also increased and their development slowed down. And we discovered this literally almost by accident. We were growing cactus anyway for another experiment, and we had space in our growth chambers. So we thought, why not just put dung beetles into the chambers and see what happens to them? And what we did effectively was to create a time machine. We went back in time to pre-industrial levels of CO2. We then had current levels of CO2 at 400 parts per million. We went into the future 30 years at 600 parts per million, and then we went a further 50 years into the future at 800 parts per million. And what we found was an effect on the beetles developing in the soil at those concentrations. And what we found was it took them longer to develop and they emerged at a smaller size. And what was most surprising was that the difference between the pre-industrial levels and the current levels show that dung beetles are already under pressure from elevated CO2. So should we care about this? Well, obviously, I think we should, but I also think you should too, because remember, these are the animals that offer us these ecosystem services. And dung beetles themselves are important recyclers of nutrients in our environment. But they are also representatives of many, many other insects in the soil. Literally millions of species of insects spend a very substantial proportion of their life under the soil developing. So crickets, cicadas, beetles, moths, butterflies, all spend a long time under the soil as part of their development. So again, we need to think of the soil as another thin layer of skin adhering to the surface of the planet, which we depend on to grow our crops. However, microorganisms in that soil also do better under elevated CO2. They increase their biomass, they use up nutrients in the soil, and they change the alkalinity of the soil. And we think that it's this that is affecting our dung beetles developing in that soil. But we don't know. And for me as a scientist, that's actually quite exciting because it points to the next research that I should be doing. But for the rest of the planet, I think it gives us a very strong motivation to reduce our levels of CO2. We already know that we're overheating the planet with our production of CO2. But it also might be that this ubiquitous change in CO2 levels across the planet in the atmosphere is also responsible for this insect apocalypse, this decline in insect numbers. And until we know that for sure, I think our findings are a very strong motivation that we should reduce our CO2 output and safeguard the small creatures that actually run our planet.